Lesson 3. Numbers in exponential form raised to a power. Students will know how to take powers of powers. Students know that when a product is raised to a power, each factor of the product is raised to that power. Students write simplified equivalent numeric and symbolic expressions using this new knowledge of powers. So let's start with exercise 1. If I have 15 to the third 9 times, that means I have 9 15 to the thirds. So if I have 9 15 to the thirds, that means each one of the 15s in here is 3 of them. So if I just, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there's going to be 27 15s. Now what can I do with 9 and 3 to get 27? Well, 3 times 9 gives me 27. So if I have a power raised to another power, I'm just going to multiply those together. So the answer is 15 to the 27th power. What if I have 3.4 to the 17th to the 4? That means I'm going to have 3.4 to the 17th written out 4 times. And each of those is going to have 17 of the 3.4s. Way too much for me to draw out. So 3.4 to the 17 times 4 is going to give me 3.4 to the 68th power. So it's 3.4 to the 68th. The next one, exercise 3. I have negative 2 to the 5th to the 8th. So it's negative 2 to the 5 times 8. So it'll be negative 2 to the 40th. And yes, the negative must be in parentheses. So negative numbers must be in parentheses. Parent. The next one, we have s to the 17th to the 4th. Well, that's going to be a lot like the one right above it. So if I have s to the 17th to the 4th, that's s to the 17 times 4, which is s to the 68th. Sarah wrote that 3 to the 5th to the 7th is 3 to the 12th. Correct her mistake. Write an exponential expression using a base of 3 and the exponents 5, 7, and 12 that would make her answer correct. Well, 12 I can get from adding these two. So I'm going to have to change the problem a little bit to be 3 to the 5th times 3 to the 7th, not raised to the 7th power. So then I add them and I'll get 3 to the 12th. What if I have two things, like 11 times 4 in parentheses to the 9th power? That really means that I'm going to have nine of the 11 times 4. So this means I'm going to have 9 11s and 9 4s. So it's just like using the distributive property with exponents. The 9 goes to there and it goes to the 4. So my answer is the 11 to the 9th and 4 to the 9th. What about let x be a number and we have 5x to the 7th? Again, you're going to take this 7 and take it to the 5 and to the x. You have to do both because it's like having 5x, 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 1, 2, 3, 4, 5, 6, 7 of them. And they're all being multiplied, so you have 5 to the 7th, x to the 7th. Again, we're going to use the distributive property for exponents, so this 5's got to go to the 2 and to the 4. So you're going to have 3 squared to the 5th and 7 to the 4th to the 5th. Multiply those, and my answer is going to be 3 to the 10th times 7 to the 20th. So now, remember, if there's no exponent, so no exponent means that the exponent is equal to 1. So there's no exponent with the 5 or the x. So this 7 is going to have to go to the 1 there, to the 1 there, and to the 2 there. So I'm going to have 5 to the 7th, x to the 7th, and y to the 2, y squared to the 7th. So my final answer is going to be 5 to the 7th, x to the 7th, and y to the 14th. Again, the 5 needs to go to the 2 and to the 4. So we have 3 squared to the 5th and a to the 4th to the 5th. So it's going to be 3 to the 10th, a to the 20th. This 4 needs to go to the squared, to the 1, and to the 3. So we have a squared to the 4th, which is a to the 8th, b to the 1st to the 4th, which is b to the 4th, and c to the 3 to the 4th, which is the 12th. Let x and y be numbers. Y does not equal 0, and let n be a positive integer. So how is x over y to the nth power related to x to the n, y to the n? Okay, as this little example here, what you're looking at with this is this 2, this squared, has to go to each of them. That's because if I were to write this out, you'd have 2 to the 3rd times 2 to the 3rd, which is 2 squared over 3 squared, which is 4 over 9. So what we have here is we're going to have x to the n, x divided by y to the n. You're going to have this repeated n times, because this n has to go to the x and to the y. And that's the end of your lesson.